today I'm talking about like privacy and compliance, and like I will try to explain why this contradiction is like really superficial. So the apparent conflict is basically based on like very simplistic narrative that if you add privacy, then you lose compliance. So you can think about like number of personas, like regulators versus users, technologists. So regulators want like, well, compliance. They want traceability. They need to understand like what the flow of transactions looks like. They need to understand like who participates in transactions, like who are the users, why they are participating. On the other hand, we have users, and like also like from say cypherpunk era, who really care about privacy and don't want their transactions to be revealed. So the result is that we have this like contradiction that is often framed as like a zero-sum game. Either we have compliance or we have privacy. So in this talk, I want to show why the compliance doesn't equal like the total surveillance. I want to talk about regulators who really care about like outcomes, about like setting up rules, rather than the possibility of the need of like being able like to the possibility of investigating every single transactions. I will also like talk about privacy preserving techniques that allow, on one hand, show regulators that the transactions follow the rules. On the other hand, will allow users to maintain privacy. So we can categorize the compliance needs into like a number of categories. So first of all, we need to have identity rules. Like we need to be able like to separate like good actors from bad actors. We need to be able like to gatekeep our protocols from users that could be like for example like North Korean hackers. On the other hand, we have risk control. So this is also called sometimes as like a pre-trade control. So basically, we need to have like a set of rules that will determine when a particular transaction can go through. We also have auditability, and this is like a post-trade. So for post-trade, it's like when transaction went through, and after the fact, we realize that there is something wrong, right? So we can imagine a situation where we have like a number of blacklist addresses, like the number of addresses that we identified to be connected to, for example, Lazarus Group, and we don't want them to participate in our protocol. But for example, we didn't update the blacklist on time. So like particular transfer from Lazarus Group went through. In that case, we want to make sure that after the fact, we can audit the protocol. So let me introduce like the cryptographic toolbox that we are going to use in the rest of the talk. So these are like, I would say, the usual suspects, right? So we have encryption to ensure like privacy. We have zero-knowledge proofs to ensure security, and also they play like a very important role in ensuring privacy as well. We have accumulator schemes like Merkle trees, also like for the sake of efficiency. And finally, we have signature schemes. So before continuing, let me set up the stage for basically how private transfers often work in many protocols you see. So this paradigm that I'm going to like briefly present was created by Zcash, or like Zero Cash, Zero Coin, like this team that came up with these great ideas of like putting like privacy for transactions on chain. So basically, what we have a user that wants to transact privately, and we have a smart contract. In this smart contract, we maintain two trees, like Merkle trees accumulators, right? There's a tree of commitments. So these commitments are commitments to the nodes. To the nodes we are going to later spend in transfers. And we have nullifiers. So nullifiers are needed to prevent double spending. Basically, the idea here is that when you are sending a transaction, when you are sending a node, you are revealing like the nullifier connected with the node in a way that the nullifier is added to the tree of nullifiers, and then when you are trying like to spend the same node again, the same node should have the same nullifier. So basically, you see like that the nullifier has been already used, and the second transaction, the second attempt is not successful. So for identity, like this is like a very simplistic concept, and like basically what I'm going to present here on a paper looks like super simple, but the devil is in details, and like implementing all of these things is really like super challenging. So for identity, we have like some authority that signs some documents, and then the user can take the signed document and using zero-knowledge proofs can show that the document has certain properties. But then there's like a number of challenges. So first of all, there are really lack of adopted standards for identity, something that everybody would agree on. Later, ZKPs are not really considered, they're not recognized as proofs. And this is like something that is really annoying. So basically, when you are talking to regulators, they don't want to see like a ZK proof for the fact that something took place. They want to audit like everything step by step. And this is like a very, very challenging thing that we need to overcome. We need to like convince the regulators that ZK proofs are good tools for audits. Finally, like KYC is only part of the process. There's also KYB, which comes with like much heftier paperwork. And it's like there's another like level of complication. So for risk control, so this is pre-trade privacy. We are focusing on like giving like some rules such that transactions that don't follow specific pattern are not going to be processed in the system, right? And for this, we can take an example from privacy pools, which I believe were discussed earlier today, where basically users are showing that their funds come from so-called association set of like good actors. And in that way, they are allowed to trade in the system. For post-trade privacy, we can use the idea from Zcash, which introduced so-called viewing keys. So Zcash gave their users like possibility to reveal their transactions by deriving so-called viewing keys from users' spending keys, so from the key that is needed to send transaction. And when this viewing key is revealed, the auditor can check like the whole trace of the transactions. Right. So of course, like there is also like some issues with that. So for example, like the auditor learns basically everything. And finally, we really can like extend this framework. So instead of only like thinking like very quite simplistic that we have only like a set of allowed actors that can participate in the protocol, we can introduce like metrics for transactions that they need to fulfill to be processed. So for example, we can set caps for how big the transaction can be to be processed, or we can think about like systems where basically different amounts of transactions require different checks. The problem with viewing keys, as I mentioned, is that the authority who keeps the viewing keys has like the like full control of, I mean, maybe not control, but has like the full view of like how the transactions were processed. And we can like improve this process by doing by distributing these viewing keys in a threshold manner, like among like multiple regulators. So for example, we can think about a system where we have like 5 governing bodies, and like if 3 of them agree that there's something suspicious going on, then they like get together and reveal the transactions. And finally, we can think about system where by using zero-knowledge proofs, we don't need to reveal the transactions, but only like a proof that some predicates about transactions hold. So for example, if the auditors are interested in checking the fact that, I don't know, like the transactions were transmitted to John X, the user who sent the transactions can provide a proof that no such transaction took place without revealing the whole trace of transaction the user did in the past. Finally, we can think about hidden policies. So it might be the case that when you have different policies for different roles in the system, then like the sole fact that you are using certain policy also tells something about yourself. So we also can use zero-knowledge proofs to hide the policies. So I would like to conclude this presentation with telling that basically this is like a sort like privacy and versus compliance is like a design space. It's not like a dilemma, right? We need to think about regulators as first-class citizens in privacy-preserving systems, to convince them about like the system tools that are robust enough to provide them the information they need in a verifiable way. And also like to have some sort of knobs that allow us to turn the system in a way that meets the regulatory requirements. Thank you very much.